Don't you think this should be National Trucker Day? I mean, it's 10-4. Shouldn't that be National Trucker Day? Okay, if you don't get that. We are on 2.2, the ballerina section, and continuing with power functions with modeling. So yesterday we were talking at the end about power functions, and we looked at these two examples, and we talked about how cube roots were 1/3 power, so you could have fractional exponents or you could have negative exponents. And we looked at the k values, the constant of variation, and the powers. When we mention the phrase analyze it, we do talk about, do you know what's going on the far right and the far left of the graph? Do you know whether it has vertical asymptotes or horizontal asymptotes? I mean, what is this information telling you right here? What is that information in the red telling you right there? The limit as x goes to positive infinity is 0. What's that telling you? You're going this way on the graph a long way. It's telling me there's a horizontal asymptote right there. Y equals 0. That's one of the end behavior things that we talked about in chapter 1. Points of discontinuity. Does this graph on the right have any points of discontinuity? So, let's see, points of discontinuity. Okay, so what's the point of discontinuity? X equals 0, that's true. What type is it? Infinite, removable, or jump? That is infinite, yes. Okay, you need to know those kind of things. What's the limit at 0? What's the limit at 0? Now notice that's not a right or a left, or from the right or from the left. That's at 0 itself, so it's the overall limit. So if you say 0, then you think that the y values from the right and from the left are both coming at that point right there. Okay, so what do you think's going on? That's D and E. You're right about that. That does not exist. From the right, it's positive infinity. From the left, it's negative or positive infinity also. Or does not exist, as the case may be. You could say either one of those. So I did include in your notes the analysis for both of those, which comes from the textbook, yes. I'm not going to ask you to do all of that stuff in one question again, but I might ask you for individual pieces of information out of that, and you need to be able to look at the graphs and answer those questions. There's too much to be asking all of that at the same time. Oops. That mark. Now, this is a very specific, I'm not going to be asking you to name monomial functions. This is a specific type of power function, because the exponents are all positive integers, like y equals x squared, y equals x cubed. These are the ones you see a lot of times in Algebra 2. Okay, so like the cube function. You've seen that before. Now, when we get into graphing these things, we need to think about these. They basically have two types, don't they? One type looks like this. The other type, which would be like y equals x squared kind of, is based on this. What's the difference between that and, let's say, if I asked you to graph y equals x to the 5th, what would that look like? What'd you say about the ends?
The ends would still be going in opposite directions.
Sure, it's an odd powering function, or an odd degree. So definitely, based upon the leading coefficient being positive, we know that the right-hand behavior would be up. Based upon the degree being odd, we would know the left-hand behavior is down. That's that stuff that we talked about from polynomials. Because this monomial function is in both categories, power function and polynomial function. Okay? What you're going to find out is that it's very similar. And the higher the exponent gets, the steeper the sides get. And the sharper the turn gets. But they all have 3 points in common. Can you name one of those 3 points that they all have in common? 0, 0. Thank you very much. Name another point that those x to the 7th, x to the 9th, x to the 11th all have in common. 1, 1. Yay, we got it. That's another one, right? So we got 0, 0, and 1, 1. What's another one? Negative 1, negative 1. They all share those 3 points in common. Okay? Well, what about y equals x to the 4th? That kind of thing going on. So y equals x to the 6th, x to the 8th, x to the 10th, they all have that similar shape to them. Can you name 3 points that they have in common? Whoa, I missed kind of. 0, 0, yep. 1, 1? Negative 1, 1, yeah. They all have that very similar shape. We can talk about what happens when you graph these things. So, think about your fireproof form here, y over something equals x cubed. What are you going to do to get this thing in fireproof form? Y over 2, can you describe to me what's going on? What's going on right there? That's a vertical stretch by 2. So, you take your x cubed function and you stretch it. That's kind of hard to graph, folks, because you really have to have those points, individual points, in order to see a vertical stretch on that. What about over here? What would you do to get this letter B in fireproof form? Divide by what? Negative 2/3. So 2 things are going on here. This and that. It is reflected across what? Across the x-axis, that's right. And what about that? That's right, vertical shrink of 2/3. So, it's a little bit hard to show this. This, I guess, maybe would be a little bit wider than I'm drawing it, but definitely reflected. Because you're pulling all those points closer to the x-axis. So everything has a base, all these even and odd powering functions have a very similar shape to them. Yes? Is that what you wanted? Okay. Sure. Okay. Now, before we look at the pictures that are there, what does y equals x look like? Yes! 1970s disco. Staying alive. You know, exactly. All right, so we got the y equals x. I'm only dealing with quadrant 1 at the moment. What's the exponent on that powering function? That's a 1, right? Okay. What do you think about y equals x to the 3 halves? Do you think that 3 halves is bigger or smaller than 1? Do you think that 3 halves is bigger or smaller than 1? Bigger, right? 3 over 2. Numerator is bigger than the denominator. Has to be bigger. So guess what? Do you think that the graph of this green one is going to be below that line or above? Well, most of it is above, but not all of it. Okay? Because from 0 to 1, those are fractional values, and it will be below until it reaches this point. Fractions do weird things. That's why on SAT questions, they start throwing things at you like, x is from 0 to 1. Well, now they want you to realize or think about when you start raising something to a power and it's a fraction, it actually gets smaller. How about y equals x to the 2/3? Is 2/3 bigger or smaller than 1? It's a smaller value than 1. So what do you think is going to happen? Is it going to be above the red line? Below the red line? Most of it is below this section here, and then it goes like that. Now this is only what's happening in quadrant 1. Some of these functions have more going on than just quadrant 1, but not all of them. What happens when it's negative? Y equals x to the negative first. Is there another way that you wrote that in algebra 2? 1 over x, that's true. Remember we talked about that yesterday with fractions and moving things from denominator to numerator, numerator to denominator. The signs on the exponent change. So this is y equals 1 over x. What's that look like? Especially in quadrant 1. What's that look like in quadrant 1? Some of you can do it. What? Did I see it in your brain? Do you see the 1 over x? Quadrants 1 and 3. Here, I'll do it backwards for you guys. Quadrants 1 and 3.
Mr. Taylor, can you do it like just
Larger? Like, I don't want to hit her. Is that what you're getting at?
No.
Okay. No, there's no videotaping.
Don't worry.
But I would say, if you've got like two, people that are attacking you coming from both sides, right? The little 1 over x. I'm telling you, it's a great defense move. Use your mathematical models to help you. So quadrant 1, it would look like that. Now, they all go through what point? 1, 1. Truth of the matter is they all go through the point 1k. Why do all mine go through 1, 1? Because I kept choosing the k value of 1 every time. And then the ones that are positive all share another point. What else do they share? They all share 0, 0. Now, some of these can handle, and we'll talk about this in a second, some of them can handle odd, or some of them can handle negative numbers, and some of them can't. We'll talk about that in a minute. What happens if you multiply all these by negative 1? What happens if you flip them, right, over the x-axis? And so that's the picture that they're showing you here, is that if k is positive, your quadrant 1 stuff looks like this, and if k is negative, then it flips all over the x-axis. Okay? That's the only thing they're trying to get at here with these pictures. Obviously, these pictures only are dealing with a domain that is from 0 to infinity. So which ones of these can handle negative numbers? It has come to my attention that some of you need a refresher about fractional exponents because you do not know what they are. So I shall draw you a picture. Now, number one, I'm not an artist, and no, this is not a nuclear bomb. Okay? It is a tree. Okay? I told you I'm not an artist. It's a 24-inch diameter tree. 24-inch diameter tree, you hit it with your car, who wins? The tree does. Because the tree has power. Okay?
Not if the car lights itself on fire.
Oh, yeah. If the car lights on fire, then yeah, they're both going down. Okay, what's under the ground? Ooh, roots. What if it's a sumo? Okay. That's good on 10-4. Okay, so fractional exponents are power over the roots, just like a tree is. Now, what kind of roots have you ever worked with that cannot handle negative numbers? Square roots. That's true. What about, ooh, I had a suggestion over on my left, even roots. Okay, what do you think about that? Could a 4th root or a 6th root or an 8th root or a 10th root, could they handle negative numbers? Well, how about the cube root? Can the cube root handle negative numbers? Where was that? Didn't we have that up here? Oh yeah, we did have that up here. We did this. We did the cube root function earlier. Can it handle negative numbers? Can you take the cube root of negative 8? Are you guys discussing whether you can handle the cube root of negative 8? Oh my goodness. 24 feet? What kind of tree are you talking about here? What kind of diameter is this thing? Okay, I guess there are trees like that. Are the redwoods? I've never seen the redwoods out in California, so I don't know. You can drive a car through, but is that about as big as they are? I mean, they're not 24 feet, in diameter. Is that realistic?
Yep.
Whoa. Wow.
So is that a redwood tree?
The conclusion that you should have made is correct. You were right. Even roots can't deal with negatives. Do not include the negatives. I guess that's a really poor way to say that. Can't deal with the negatives. So in other words, you'll only end up with something on the right half of the graph. Okay, now, when you go to questions like this, they're asking me whether I need to graph these things. Okay, so let's take a look at this particular function. What's going on with this? Obviously, we could move that to the other side if we wanted to. We know there's a vertical stretch of 2 going on. But what is x to the negative third? We know what it's going to do in quadrant 1. In quadrant 1, it's going to do something like this. But can it handle negatives? I mean, another way to write that is 2 over x cubed, right? Yeah, you can handle negatives. You plug in a negative, you get a negative. So you'll end up with a shape that looks like that. Do you think that's even, odd, or neither? That's odd, right? It's got that rotational symmetry around the origin. Spin it 180 degrees, it looks the same. And obviously your k value, right? K is equal to 2, and the exponent or the power, I guess they use the letter A, sorry. I'll use the letter A. The letter A that they used is a negative 3. On the next one, letter B. What's K and what's A? Negative 0.4. Okay, hopefully you see some sort of reflection going on. And you know what? I'm wondering if it would be better off to begin with, before you do the reflection, even though you know in your mind you're going to reflect across the x-axis, I bet you would be better off to graph it without the reflection first before you, otherwise you might not get the right reflection. And by the way, on your next test, which will be over sections 1 through 4, we're only in section 2, so it definitely will be a few days before we get there, right? You know, probably not even through next week. I mean, unless, I doubt it'll be, I think it'll probably be the following. But there will be a no calculator section. So what I'm doing right here, by not using a calculator and using my brain, yes, you will be doing that too. Okay, not just, oh, let me type this on a machine. Okay. Now, what's the A value here?
Using your resources. What is it?
Yeah, well, why don't you just cheat off the kid next to you? You know what I'm saying?
I'm using my resources.
Jeez.
He suggested it. It wasn't my idea.
Mm-hmm. Right, exactly. Okay, yeah. They picked the wrong kid anyway, but okay. So, what's the A value here? 1.5, right? What is that? Don't you do that to me. I heard you over there. That was clever, though. Okay, so 1.5. Give it to me as a fraction. 3/2, thank you very much. I need to know that. Why do I need to know that? Number one, we all know that 1.5 is bigger than 1. So all of you should see the original like that. Or am I wrong? Yes, I'm wrong. Wait a sec. Y equals X was doing something like this. And you said 1.5 is bigger than that. So is the green one wrong? That's what I was asking. And you are correct. It should be going up. Like that. Yes, you were. You just backed away from your own answer. But you were right to call me out and tell me I was wrong. Now that's obviously not what, doesn't have the reflection. The question I have for you is, can that handle negative numbers? Is there something more to this graph than just quadrant 1? Okay, folks, remember my tree. Look at that fractional exponent in the denominator. What is it? What were you saying earlier? About even roots? Even roots cannot handle negative numbers. So that is the extent of this. Now, the only thing we have left to do is deal with the negative. So we should be getting a picture that looks like that. But I really am, I would be worried that if you didn't graph the one without the negative, that you might end up flipping it over the x-axis and get the wrong looking picture. So graph it without the reflection before you flip that thing over. Okay. What is the value of k? -1, so obviously we know there's a reflection going on. And how about a? 0.4 speaketh the fraction. I know it's 0.4, but what is that as a fraction? Yes, it is 2/5, even though you just want to mumble it. Yes, you are right, 2/5. Be confident, man. You are correct. Now, for those of you who don't know how to do that, you can always start out with something called 4/10. That's how you read 0.4. 4/10, and then reduce it. Okay, so it's 2/5. Is 0.4 smaller than 1? So it is smaller than 1. Therefore, if this did not have a negative, we know the shape would look like that, at least in quadrant 1. Now, can it handle odds?
Yes.
Sure, it can handle odds. Okay. What's going on up here? So it can handle odds, or the negatives, right? So negatives are okay, right? Check on the negatives. But what is that numerator doing to those negatives? Come on, it's power over the root. So what's that power doing to every negative number? Okay, well, what power is that on the top? It's a 2, right? Usually we say things like square. So you tell me what happens when you square a negative number. It becomes positive. So you thought it was going to go down here in quadrant 3, didn't you? But the square does this. That's kind of weird. Why is it doing that? Because this right here is changing all of those negatives into positives. Would that have happened if it was a 3? No, it wouldn't have. It would have been down there in that quadrant. And now, what are we doing with that? Whoa, we're flipping it. Oh.
Whoa. That's a little appropriate.
I know. Well, we didn't flip it off. We just flipped it. I'm sure some people do that to different functions that they don't want to graph, but not us. So that's a lot of information. I do understand that. We started out with the basic quadrant 1. Basically looked at it and said, okay, that's going to be lower than the line y equals x. Then we started asking ourselves, can we deal with negatives by looking at the root? We said yes. Then we had to look at the exponent above that and say, okay, what's it going to do to those negative values? If it's even, like this one is even, we knew that it was going to change those negatives to positives. That's why we thought it was going to be like this and like this. But then the negative flipped the whole thing over. I know, blow your minds. It's so cool. That'd be an awesome test question, you know? No graphing calculator. It's not that complicated, but it's got several parts to it. I like it. And yes, we'll probably have to stop there for today. Have a great weekend, children.